Let's build a random forest model in Python so you can better understand how it works. Today, we are going to be coding a simple random forest model, which is one of the most intuitive and most common machine learning models. A random forest is basically a supervised machine learning model that uses a group of decision trees to make its prediction. Now, I want you to think of a decision tree as a flowchart. It starts with the data and then repeatedly asks yes or no questions to continue splitting the data into smaller groups. Once all of the data points in a singular group at the end all have a similar prediction, the model can classify that leaf and use it for future predictions. Now, the problem with using a singular decision tree is that they can sometimes be a little overconfident in patterns that don't really have a lot of meaning. For instance, it might memorize small patterns or one-off quirks in the training dataset instead of learning patterns that generalize on new data. Now, a random forest, which is what we're building today, will help fix this because it makes many trees and lets them all vote. So instead of trusting just one tree, the model combines the predictions of many trees, which makes the final prediction a lot more accurate and stable. In today's example, we are going to use a classic beginner dataset with iris flowers. Here's the data. Each flower has a ton of different measurements, for example, petal width or petal length. The model's job is to look at all of these measurements and predict which flower we're looking at. Now, since the model is choosing between different kinds of labels, the iris flowers, this is a classification problem, as opposed to a regression problem where the model predicts numbers. Now, the first big thing we do in the code is separate the inputs from the outputs. The inputs are all the flower measurements we just talked about because that's what the model needs to examine to make its prediction. On the other hand, the output or the answer or the target is the correct flower species because that's what we're trying to predict. Now, this type of learning is called supervised learning because the model is trying to learn from data where the correct answer is already provided. And if you're curious, I have a beginner supervised machine learning course coming out very soon in case you're interested. The next thing we do is split our data into training data and testing data. Now, this step is really important for multiple reasons. Main reason is that we do not want to test the model's ability on the same exact data it learned from. That would be like giving a student a test where they already know all the answers. It's pretty useless, right? Instead, we let the model learn on one portion of the data, which we usually allocate 80% to, and then we test it on that remaining 20% to see if it can generalize to new data points it's never seen before. Now it's time for my favorite part, which is to actually create the random forest model and train it. During training, the model builds many decision trees. Each tree looks for different useful patterns in the data. One tree might rely more on petal width, one might rely more on petal length, and other trees might find different nuances in the data that they cling to. But because the trees are not all exactly the same, they each bring a different perspective. Now, once all of the trees have been trained, the model is finally ready to make predictions. Here's how it works. When the model sees a new flower, which is inputted by the user, like me or you, each tree makes its own individual guess about that species.